Hello guys. Good morning, all of you. Welcome to another session. Today in this session, we'll be discussing special theory of relativity. This particular topic of classical mechanics is very important for you. You have seen in almost every paper, you get a question from this particular topic of special theory of relativity. As there are many topics in this single topic of special theory of relativity, it may take maybe 2 to 3 classes, and this is the first part of this relativity class. So before I start, let me know if everything is all right. First part. Okay, I hope everything is all right. Before I start special theory of relativity, we need to know about a frame of reference. What do you understand by a frame of reference? So let us talk about it. Good morning, Ajay. How are you? Ajay, have you started watching the videos which I have uploaded in the recorded format? Tell me about them. Few videos I have uploaded in Hindi. Yes, Harry. Good morning. Start from today. So you have problem in with Hindi lecture, right, Ajay? Actually, those lectures which were uploaded in Hindi English mixed. Those lectures are like mostly in English, but the overall language has been kept in. So you may face little bit of problem in understanding those Hindi parts. So that is why I was thinking to take, let's say, 2 sessions a day to cover all those uncovered topics in English as well. So what do you say? There will be no problem? Okay. So what we have decided, we'll first cover whatever topics are left first. Okay. Once those topics are over, we'll go for those topics for which the videos have been uploaded in Hindi. So you see, we have covered mathematical methods of physics entirely, nuclear particle physics entirely. So there is no issue. Should cover the detailed course. Now, as far as the Hindi lectures are concerned, we have uploaded maybe I think classical mechanics, quantum mechanics, and electromagnetic theory. Electromagnetic theory, few portions like interference, diffraction, and all those topics, those are not covered yet. We'll cover in the upcoming classes. So mainly we have to retake those classes of classical mechanics, quantum mechanics, and EMT. So those will be taken nicely, but in the meantime, those who are able to understand and those who do not have any problem, you can just go through them. When we'll cover them again, it will help you to understand it more better. Anyways, with that, yes, Harry, I understand. So we'll take those classes again, don't worry. And those who do not have problem, they can watch it beforehand. Okay. So what is a frame of reference? Frame of reference is that is a place, you can say, from where observations are made. So in the language of physics, if we talk about a frame of reference, how it is done, let's say you are okay. A frame of reference is the place where from where you make observations. So let's say this is our coordinate system XYZ. If you want to denote any point, you need a coordinate system, right? So let's say you are an observer. So with respect to this frame, you are making the observations. So in a frame of reference, we need three quantities, let's say X, y, and z. In the discussion of special theory of relativity, we measure another quantity, that is time. So a clock is also associated with the frame of reference, and as a result we get x, y, z. And whenever you represent a point by x, y, z, it is the coordinate, okay, space. Now when you also include time, so it is your space time, then any point will be called as an event. Understood? Event means specifying x, y, z and its time also. So this is a frame of reference. So the basic definition is a place from where observations are made is called the frame of reference. So frame of reference, if I talk about frame of reference, as you can see in this picture, it is consisted of a coordinate system, with respect to which you will specify the spatial coordinate. These are called spatial coordinate. And this is the time component, time coordinate. A coordinate system for spatial coordinate, plus we also associate a clock for the time coordinate. So event means x, y, z. So whenever a rest frame we consider, we represent it by, let's say, S frame. Rest frame is S frame, or conversely you can say S frame is rest frame. Now any frame which is not at rest, which is moving with some velocity, will denote them by S prime. Okay, S prime. So remember this one rhyming: S frame is rest frame, S prime frame is moving frame. Okay, so you have understood the frame of reference. Now how many different types of frames of reference exist? Let's talk about them. Types of frames of reference. So there exist two types of frame of reference: inertial and non-inertial. So the first one is inertial frame of reference. What do you understand by inertial frame of reference? Anyone has any idea? Look, inertial frame of reference, if you want to define, you need at least two frames. The inertial frame of reference are those frames which are at rest or moving with constant velocity with respect to each other. So two frames are said to be inertial if they are at rest or moving with constant velocity with respect to each other. The inertial frame, the best example is the Earth's surface, the laboratory frame. Those are inertial frames which are at rest. Okay, so let's say you are standing on the ground and your friend is riding a bike, but he is riding a bike at a constant speed, let's say 40 kilometers per hour. So you and your friend are in inertial frame of reference. So you require at least two frames to define an inertial frame of reference. If you are at rest, you are at rest with respect to someone. Okay, let's say two trains are moving side by side. Now if they are moving with constant speed, a person sitting on one train, he will see the another person sitting on the other train stationary. Okay, but a person which is standing on the ground, he will see that that person is moving. So it is, we need to define a frame with respect to which we are observing. So depending on the frame of reference, the motion, the observer may decide whether it is at rest or it is moving with some speed. Okay, so that is why whenever we want to define inertial frame of reference, we need at least two, because we have to say with respect to which frame he is at rest. Okay, na? One example, you are standing on the ground, your friend is riding a bike. So you will see your friend is moving with some velocity. Now imagine another friend is sitting behind the bike, sitting on the bike. So he will see that biker to be at rest, but with respect to you who is standing on the ground, he will see them moving. So you need two frames to define whether it is inertial or not. So whenever we will define a frame, we will draw something like this. So this is the rest frame, let's say x, y, z, and a clock is there. So if I consider this is the S frame, this is the rest frame. Now another frame is there, and this frame we denote by, let's say, okay, let's do one thing. Whenever you will draw the coordinates in this relativity chapter, you will take this as x-axis. It will help us. Then y, and then previous also you can just change the symbol. It doesn't matter which axis we take, but you have to follow a certain procedure. Let's say if you go from x to y, it should point to z. You see x and y there. If you just rotate something from x to y, it will point out to z. In that way, these coordinates are defined. So x to y, it is pointing out to z. S prime frame is moving with constant speed. This is your S prime frame. So here the coordinates will be x prime, y prime, z prime. So these two frames, S and S prime, are said to be inertial frames. Here S prime is moving with constant speed v with respect to whom? With respect to S frame. And therefore we can say S and S prime frames are inertial frames. Clear? And whenever you want to define any point or any event, or better I say event, in the S frame, it will be denoted by x, y, z. And if I take a time coordinate also, so x, y, z, t. Here, the same thing. We are looking at the same point. Okay. So, okay, just do one thing. You have an event here. Now a person is standing in the S frame and another person is standing on the S prime frame. So this person will measure this event as x, y, z, t, and this person will measure this same event as, let's say, x prime, y prime, z prime. And now in relativity we try to find out the relation between these coordinates. What is the relation between x prime and x, y prime and y, z prime and z, and t prime and t? So this is inertial frame of reference, and all the discussions on special theory of relativity will be done by taking inertial frame of reference. Another frame of reference exists, that is a non-inertial frame of reference. Non-inertial frames are those frames which are accelerating or rotating. So there's two types. It may be accelerating or it may be rotating. So you do not need another frame to define that. One frame of reference is sufficient. If something is rotating, it will rotate with respect to all the frames. Non-inertial frame of so it is a frame of reference said to be non-inertial if it is either accelerating or rotating. So if you have a reference frame like this, let's say this is x, this is y, and this is z. If it is accelerating, then this frame is said to be non-inertial. It doesn't require another frame with respect to which we will measure. It doesn't require. Now let's say this is x, y, z. Now this frame is rotating. So after rotation, let's say this x-axis is coming here. It is rotating about y-axis. X-axis will come here and z-axis will come here. It is a rotating frame. Rotation are being taken place about y-axis. So this is either accelerating or rotating. So these are the examples of non-inertial frame of Is force 0? No. It is just about the frame. You imagine like whatever we observe in our Earth surface in the laboratory, they are all inertial frames, right? So if some force is 0, then it is 0. If some force is not 0, it is not 0. Inertial frame is a laboratory frame, and non-inertial frame may be a bike is accelerating. Okay, you are moving, you are enjoying a merry-go-round, so those frames are rotating frames. So these non-inertial frames are not taken into consideration in the discussion of special theory of relativity. So that thing we have told you that we need at least 2 reference frames to define the inertial reference, and that we will talk about. So we define 2 inertial frames. Whereas we define single non-inertial frame. Because absolute inertial frame does not exist. Velocity constant due to the acceleration is 0, f is 0. Oh, yes. With respect to this S frame, the velocity is constant. So we can say with respect to S frame, the acceleration of the S prime frame is 0. That is why it should be moving with constant velocity, right? So acceleration is 0. So this is not accelerating frame. So that is why S prime is not a non-inertial frame. So you imagine it in this way. Okay, it is not, we are not talking about the frame, we are talking about maybe some event. So let me give you one example. Let's say, okay, that's a genuine question Murli has asked, so let us talk about it. What we do in STR, let me just, what we do in STR, special theory. Let's say a bee, madhumakhi, a bee is there. Okay, this bee is moving. Now it can have a certain coordinates, right? So what we do, we observe this bee with respect to 2 frames. I am not showing all the 3 axes, only the x, only x axis is important. So we are carrying out, this is your x axis, this is your x prime, this is S frame, the rest frame, and this is your S prime frame or the moving frame. S prime frame is moving with respect to velocity v with respect to this S frame. Now as I have told you, here we have associated a clock also, and here one person is observing from S frame, and here another person who is observing from S prime frame, and here also another clock is there. This clock measures the time in terms of t, this clock measures the time in terms of t prime. Now in STR, our job is to how this bee is changing its coordinates, its velocity, its acceleration. So if I look at the coordinates, let's say the v is here. Now if it goes to at this position, so how it changes, how its position changes. So here let's say if this observer makes the position coordinate, he will note down xy. If this observer note down the same position, he will make x prime, y prime, z prime, t prime, right? Now let's say this B is moving from this to this, so it will have its velocity. So its velocity will be, let's say, u with respect to this S frame. So u will have three components, ux, uy, uz. This person will measure the same velocity of this B as u prime. So u prime will have component x, ux prime, uy prime, uz prime. Let's say this B is accelerating. The frame should not be accelerating, or the B can accelerate. Whatever things are happening around, they can be there as usual. Only these frames should be inertial in nature. So if some force is acting on the B, let's say, he will measure the force to be F, he will measure the force to be F prime. So in special theory of relativity, we try to establish a relationship between these two measurements. Okay, am I clear? So we are not studying the motion of the frames, we are studying motion of anything with respect to these two frames. This is what it is. I hope everything is all right now. Now there are two postulates of STR. Postulates of special theory of relativity, we denote it by STR. What are those two postulates? First postulate is the laws of physics. The laws of physics are the same in all inertial frames. Understood? Number two, the speed of light. Speed of light in free space. Sure. Has the same value in all inertial frames. Let's say a photon is moving, right? You have a photon, so this photon will move with speed c. So if you measure it from a reference frame, let's say S, or a reference frame which is moving with respect to S frame with a velocity, let's say v. Here it is x prime and this is x. S is S prime moving with respect to. So an observer standing here, he will measure the speed of light to be c. An observer standing at this reference frame, he will also measure the speed of this photon to be c. So S and S prime both are inertial frames, and with respect to both the frames, photon is moving with respect to. For other velocities, it may be different. Okay, now if you consider the velocity of the B, if B is moving, that velocity will be different with respect to S and S prime, but only exception is the speed of light. Speed of light will be same in all inertial frames. Now, before I go to the Lorentz transformation, let us try to understand the Galilean transformation. Then we'll find a loophole in the Galilean transformation that will be removed in the Lorentz transformation. So, Galilean transformation. So, as I told you, we need to establish a relationship between the coordinates. So, Galilean transformation was initially taken up to establish the relationship between the different coordinates. Okay. Galilean transformation, in short GT. So what we do in Galilean transformation? As usual, we will take two inertial frames. So this one will draw many times. Okay, like almost in all the cases we need to draw this. Okay, let's draw the z axis as well. Z axis we do not show generally. So this is your S frame, the rest frame. This is the S prime frame, the moving frame. Is moving with respect to V. So keep everything same. This is X, this is Y, and this is Z. Here it is X prime, Y prime, and let's say we have an event here. Let's say that is denoted by. So if an observer makes it from this frame, its coordinate will be X, Y, Z. Okay, and time may be t. So how do you represent X, Y, Z? Imagine this, both the frames was at this point, at the center. Let's say this is O, and now it is O prime. So let's say these two reference frames were coinciding here. Now if the speed of this S prime frame is V, after some time t, we have plotted this. Okay, at t equals to 0, let's say both frames are coinciding. Now this S prime frame has started to move with constant speed V. This is the picture at time t. So how much distance it has traveled in time t? Actually, this much of distance it has traveled in time t. So can you tell me what is this value? If this S prime frame is moving with respect to S frame with a velocity of v, after time t, how much distance it will cover? It is vt, right? Now you see, with respect to O prime, if you want to go to this p, it will be X prime, Y prime, Z prime, right? So if I talk about this much of length, what is this length? This length is X prime. But if I talk about this much of length, what is this? This is X. Look at it very carefully. This much of length is X prime. This much of length is X. Clear? So Galilean transformation gives you this idea. So you can see X is equals to X prime plus Vt, or alternately you can write X prime is equals to X minus Vt. Can you write it? Now you see Y prime is same. If you consider with respect to S, Y prime is Y, that is why Y prime is equals to. And what about Z prime? Z prime is also same. Only along X direction it is moving, so only the X coordinates are changing. So these transformations are called Galilean transformation for coordinates, GT for coordinates. Now let's say this point is not fixed here, this point is moving. So this person will measure some velocity of this point, and this person which is standing on the S prime frame, he will also measure this velocity. So this person will measure the velocity as u, and this person will measure the velocity as u. prime. U means specifying components ux, uy, uz. U prime means specifying component ux prime, uy prime, uz prime. So this is gt for coordinates. Now if you take different derivative, differentiating with respect to time, so what you get, this will be dx prime by dt. So dx prime by dt is ux prime, right? If you take the derivative of the x coordinate, this will give you the x component of the velocity, right? So ux prime is equals to ux minus v, uy prime will be uy, and uz prime will be uz. This is understood? You see, it is like dx prime by dt, that is ux prime, dx by dt ux, and v is constant, so v remains, and dt by dt is 1. dy prime by dt, so that is uy prime, and dy by dt is equals to uy. So this is, and so on. This is gt for velocity. I hope this is clear till now. Now this point P may be anything, whatever you are observing. It may be a bee, it may be a car, it may be a bike, or anything which you are observing. So you can imagine it in this way, although it is sounding absurd. S prime, maybe you are standing on the ground. Okay, you are observing from the ground, so you are at S prime. You are at S prime. Now your friend is moving a bike with constant speed, and he is also watching with you. So he will be S prime frame. Now a B is moving. So you are measuring it from S, and your friend who is on the bike, he will measure the coordinates and everything in terms of S prime frame. Now this is the gt for velocity. Now acceleration, if you do further differentiation, so you get ax prime is equals to ax, v is constant, so that is not producing anything. Ay prime is equals to ay, az prime is equals to az. So this is the gt for acceleration. Now why this Galilean transformation failed? It failed because of the second postulates. Okay, what does the second postulate says? Speed of light in free space are the same value in 1 year. Okay, acceleration we have talked about. So what is the force? Force is mass time acceleration. So in Galilean transformation, force was also equal. Acceleration frequency equal. So as per this Galilean transformation, force is also equal. Now where gt fails, that is what we are interested in. gt fails to account the second postulate of special theory of relativity, that the speed of light remains same in all inertial frames. So here we have taken two inertial frames, x, s and s prime, so the speed of light should be same. Now what is the speed of light with respect to s frame? Now okay, let's say instead of now p, let's say a photon is being observed. A photon is being observed with respect, which is moving with respect to c. So as per s frame, what will be the speed of the photon? If let's say p is a photon, and let's suppose it is moving along x-axis with speed c with respect to s frame. That is, this is talking about the x component, so ux is equals to c, right? So according to gt, the speed of the photon in s prime frame will be, tell me what should be the speed of this photon in the s prime frame? It will become ux prime, right? So what is the formula? Ux prime is equals to ux minus v. V is the speed of this s prime frame with respect to s. So we will just put it into the formula ux minus v. Ux is what? Ux is the speed measured by s frame. That is c minus v. But what it should have been? It is not equals to c. As per the second postulate, these two speeds should be same. But you see, the speed of photon we are getting in s prime frame to be c minus v, which is not equal to c. Thus we see that Galilean transformation does not give result in accordance with the postulates. Hence, it is not correct and needs to be modified. Yes, c minus v, it would have been c, right? As per the second postulate, speed of light in free space has the same value in all inertial frames. Now, to make it compatible with the special postulates, Lorentz did some Einstein basically did some modification. And later, another scientist joined in, Lorentz, and the overall transformation was named as Lorentz transformation. Now, Einstein did, but Lorentz did it before. As Lorentz did it before, that is why Einstein's name is not given. It is given to the one who did it before. Lorentz did it before Einstein. Okay. Those are called Lorentz transformation. So what are the modifications done in the Galilean transformation? Let's talk about that. That is given by Lorentz transformation. It is called LT and GT, Lorentz transfer. So previously, as you have seen, okay, let's draw the coordinates that will help us. Okay, same coordinates you draw. So as per Lorentz transformation for coordinate was given. Here we talk about event. S measures this x, y, z, t. S prime measured it as x prime, y prime, z prime, and clock, t clock. Now Lorentz transformation for coordinates. It is slightly different from the GT. Here we write x prime. Previously it was x minus vt, right? So here it is not only x minus vt, a factor of gamma is multiplied. This gamma is greater than 1. Gamma is equals to 1 upon root over 1 minus square by, what is v? V is the speed of this s prime frame with respect to s, and this is always greater than 1. Y prime will remain y, z prime will remain as. Okay, so this extra modification was done by Einstein. This factor of gamma was introduced by Einstein. Now the transformation of time t prime is equals to gamma times t minus xv. As per GT, there was no role of time. Time was same in all the frames, in both the frames. But here for Lorentz transformation, time is also changed as per this formula. T prime is equals to gamma into t minus xb by. Now these are Lorentz transformation for coordinates, and inverse transformation also exists for coordinates. Those are called inverse Lorentz transform. Inverse Lorentz transform for coordinates. So you see, it is like here you are given the things in x, y, z, t. You are finding it in x prime, z, y prime, z prime, and t prime. The reverse may be also given. You are given in the moving frame. You are given the coordinates in the moving frame. How will you represent them with respect to the s frame? So you just notice one thing. If s prime is moving with respect to v, okay, so with respect to s prime frame, what is the speed of s? You imagine you are standing on the ground, okay, you are standing on the ground, and a car is moving with constant speed. So car is the s prime frame, you are at the s frame. With respect to you, the car is moving with speed v. Okay, now imagine a boy is sitting inside the car. Okay, so what he will see? He will see that this person is going away from him with respect to v, but in the negative direction, right? You will see on the ground to move the car with respect to v, but the boy inside the car will see you to go away with respect to v. So in inverse Lorentz transformation, we will just replace v by minus, that is what it is. So inverse Lorentz transformation, so this will become x, gamma will remain same, x prime, and wherever you see v, you will write minus v. It becomes plus. Y will be y prime, z will be z prime, t will be gamma t prime plus x by x prime b by c square. Above equation from where the observations are made. If observation is made from this phase, you will see x, y, z and t. If observation is made from x prime, you will see x prime, y prime, z prime and t prime. So it is just giving you the relationship between these two measurements. So you can always remember this example. You are standing on the ground, you are S frame. Your friend is moving on a bike or a car, let's say, with speed v, is inside the car. Both of you are looking at the motion of a bee. He will see the coordinates as x, y, z, t. And he will see the coordinate as x prime, y prime, z prime, t prime. Now both of you measure this. Now someone asks you what is the relationship between them. Then you can use these relations to establish a relations. Okay. Clear? Any question if you have, you can ask. Whatever question you have, because this is very fundamental thing. If this is not clear, remaining things will not be clear. So be clear from here only. It is just the two frames with respect to which we are measuring things, nothing else. When we are measuring with respect to S, there will be no prime. When we are measuring it with respect to S prime, for all quantities it will be S prime, like x prime, y prime, z prime, t prime, etc. V is same. V is the speed of S prime frame with respect to S. That is why it is V. Clear? Let's move on. There is no question. Let me know. Now let us talk about the differential form of Lorentz transform. Now you imagine, instead of looking at one point, you are simultaneously looking at two different points. Okay, let's say 2 points are there. Differential form of Lorentz transform. LT. So it is like S frame is rest frame, S prime is a moving frame which is moving with respect to V, with the speed V with respect to S. Now let's say we are observing, I am drawing it here, it doesn't mean we are only observing with respect to S. Okay, na? The point may be anywhere. I am drawing, we can draw same thing here also. It is not, it doesn't mean that it is a specific only about S prime. So let's say we have a point here, XYZ. Let's say another point here. So if I measure it with respect to S, it will be like x1, y1, z1 and t1. And the next point, point 2, let's say, will be x2, y2, z2 and t2. The same thing which we will measure from S prime frame will become x1 prime, y1 prime, z1 prime, t1 prime, the next 2 prime, y2 prime, z2 prime and t2 prime. Now the difference between them will be, if you take the difference in coordinates of x, so x2 minus x1, y2 minus y1, z2 minus z1, t2 minus t1. So this difference is in S frame. Now in S prime frame, the same difference will be x2 prime minus x1 prime, y2 prime minus y1 prime, z2 prime minus z2 prime, z1 prime, t2 prime minus t1 prime. So if I write it as delta x, the same thing will be written as delta x prime. Okay. So if I am, let's say, writing delta x, it is nothing but x2 minus x1. Delta y is equals to y2 minus y1. Delta z, z2 minus z1, and delta t, t2 minus. So this is one event, this is another event. Now the same thing we can write for, let's say, the prime case. So delta x prime is x2 prime minus x1 prime, y delta y prime, delta z prime, right? So here in the differential form Lorentz transformation, this relation is explored. So we know that x prime is equals to x minus gamma into x minus vt. Look, inverse Lorentz transformation we generally don't see much, but okay. So in the differential form, it becomes like taking derivative, delta x prime, gamma delta x, v delta t. V is constant, so it is not affected. Gamma is also constant. So this is the differential form of this. So delta x prime is like x2 prime minus x1 prime. Delta x is x2 minus x1. Delta y prime. Y prime was y, so delta y prime will be delta y. Z prime was z, so delta z prime is equals to delta z. So you can also represent it by d. Delta t prime, it was gamma times t, so it becomes delta t minus v by c square. These are constant and x was there, so x. You can also express it in this way. You can also write it in terms of dx. Dx prime is equals to gamma into dx minus v. Sometimes we represent it dy prime is dy, dz prime is equals to dz, and dt prime is equal to gamma times t minus v by c square. Okay. So these relations are used to find the spatial difference. Spatial difference means it may be delta x prime, delta y prime, delta z prime, or a spatial separation, or time difference. Between two events. Events means you have understood, right? Event is the like any point in the space-time coordinate system. In space-time coordinate system, we have spatial coordinates x, y, z, and time coordinate t. Now, if two points are simultaneous, what does it mean? Let's say, if I say, if two points or two events are simultaneous, two events are simultaneous. What does it mean? If I talk about, let's say, S frame, so one point is T2, another point is T1. If they are simultaneous, means T2 minus T1 is 0. And if two events are simultaneous in, let's say, in S prime frame. It means one event is having time t2 prime, another event is having time t1 prime. They are simultaneous, means that the gap is 0. Okay. So this is the meaning of simultaneous. Means delta t prime is equals to 0 or delta t is equals to 0, depending on the frame which you are talking about. So I hope it is all clear till now, and you will see most of the problems will remain in this theory part only, whatever we have discussed till now. Let's try some problem. Too many pages we have this. Give it a try. Two events separated by a spatial distance of 3 × 10⁹ meters simultaneous. In one inertial frame, what is the time interval between these two events in an inertial frame moving with a constant speed 0.6 c? Do it quickly. What it has asked you? You always need two frames, because in STR we will always deal with inertial frames. Is S frame, rest frame, S prime frame moving with velocity v. So two events separated by spatial distance of 3 × 10⁹ meter. So two events, let's take two events. This is one event, this is another event. It is separated by 3 × 10⁹ meter, are simultaneous in one inertial frame. It does not say which one. What is the time interval between these two events in an inertial frame moving with a constant speed 0.6? So obviously 3 × 10⁹, this is your delta x, right? This v is 0.6 c. Two events separated with spatial distance are simultaneous in one inertial frame. It is talking about S frame. So delta t simultaneous means delta t is 0. What is the time interval between these two events in an inertial frame moving with a constant speed 0.6 c? It is talking about what is your delta t prime. It may come to be negative, but it is the difference. Okay. So whether even if you get negative result, that you will consider only the magnitude. Time cannot be negative, right? Do it quickly. Could find the answer. Everything is mentioned. Why it is taking time? Should not take much time. Everything is mentioned here. What is delta t prime? Just put it into the formula. Delta t prime is equals to gamma into delta t minus v by c square delta x. Just put it. Gamma is what? 1 upon root over 1 minus v square by c square. So v is 0.6, so v by c whole square, so 0.6 square. Delta t is 0 minus v by c square, v is 0.6 c, delta x 3 into 10 to the power 9, 1 c is cancelled from the denominator. So here you can put 3 into 10 to the power 8. That is the speed of light. If you calculate, you will get minus 7 point. Option A. Whether you get minus plus doesn't matter, because you are taking the difference. No? There may be different time zones. You can imagine it in this way. Whatever is the time here, it will be different in Bangladesh, it will be different in USA, it will be different in Indonesia. It may be positive or negative. Some countries are ahead of us, some countries are behind us. Okay, I hope you have understood this one. Let's go to this problem. An inertial observer sees two events, E1 and E2, happening at the same location. At the same location means delta x or delta x prime, whatever frame it is 0. But 6 microsecond apart in time. Another observer moving with a constant speed. It means it is in the S frame. Same location means delta x is equals to 0. But 6 microsecond apart in time. So delta t is equals to 6 microsecond. Another observer which is moving with constant. Whenever you see moving frame is the S prime frame. These the same events to be 9 microsecond apart. So it is delta t prime. Then what is the value of this? It is actually 1 by gamma, right? Root over 1 minus v square by c square. No, gamma is equals to 1 by root over 1 minus v square by c square. So it means you have to find out root over 1 minus v square by c square, that is 1 by gamma, right? This one you need to find. Do it quickly. What is the answer for this question? Option A, 2 by 3, very good. So delta t prime is equals to how much? Gamma times delta t minus v by c square delta x. Delta x is 0. So this is your 9 microsecond. Let's write microsecond. Gamma is 1 upon root over 1 minus v square by c square times delta t. Delta t is 6 microsecond minus v by c square into delta x is 0. So this term becomes 0, and that means 1 minus v square by root over 1 minus v square by c square is equals to 6 by 9. So 2 by 3. Option A. Yes, Murli, Ajay. Okay, let's talk about velocity transformation. This one is understood. Now let's talk about velocity transformation. So velocity transformation, you can understand it. Let's say the B is moving. Now, how its velocity will be measured with respect to a person moving, standing on the S frame, and with respect to another person which is on the S prime frame. S prime frame is moving with respect to S at a constant speed of v. Okay, so let's talk about velocity transformation. So as usual, we'll be drawing the two frames. One is S frame, another one is S prime frame. X, Y, Z, X prime, Y prime, Z prime. S frame is the rest frame, S prime frame is the moving frame which is moving with the speed v with respect to S. O is the origin here, the same origin will O prime. We are observing a point P. So we have already discussed the how its coordinates are changing with respect to different observers in different frames. Now let's say a B is moving with respect to S frame and S prime frame both. So if the speed or velocity, if we say velocity of this point is u with respect to S frame and u prime with respect to S prime frame, how these components are changing, that is what we need to do here. Ux, uy, uz and ux prime, uy prime and uz. So let's consider that ux, uy and uz are the velocity components of P with respect to S frame, and ux prime, uy prime, uz prime are the velocity components of P with respect to S prime frame. Okay, look, if we write the magnitude of u, what it will be? Root over ux square, uy square, uz square. Clear? If you write the magnitude of u prime, it will be root over ux prime square, uy prime square, uz prime square, right? No issue. How do you get ux? How do you get uy? And how do you get uz? The ux you got from dx dt, right? Uy you got from dy by dt. Uz you got from dz by dt. On the other hand, if I talk about ux prime, uy prime and uz prime, where did you get it? Where did you get it? We have got it from ux prime dx prime by dt prime, uy prime is dy prime by dt prime, uz prime is dy prime by dt prime. Now what is our goal? Our goal is to Find the relationship between ux prime and ux, ui prime and ui, and uz prime and uz, right? So ux prime is equals to dx prime by dt prime. Let's focus on the first one. So we can write what is dx prime. What is happening? Where is what is this dx prime? You know, gamma times dx minus v dt. You require dt prime, gamma times dt minus v by c square, and hence we can write ux prime, which is equals to dx prime by dt prime is equals to gamma times dx minus v dt divided by gamma times minus v by c square dx. What does it mean? It means it's dx minus v dt upon dt minus v by c square dx. Now if I divide both numerator and denominator by dt, divide both numerator and denominator by dt, so you get dx by dt minus v, and the denominator what you get, 1 minus v by c square dx by dt you will get, and that is why we write ux prime is equals to dx by dt is what, ux minus v divided by 1 minus dx. अच्छा यहाँ पे हाँ 1 minus ux into v divided by c square. Can you write it? Is this calculation clear? So this is also known as velocity addition rule. Can you calculate ui prime from in the same way? Give it a try. Try to find out ux ui prime. Tell me if you are able to do it. If you want to calculate ui prime, what you gonna do? Ui prime is equals to dy prime by dt prime. Dy prime, you know, it is dy. Dt prime is gamma times dt minus v by c square dx. Okay, so if I divide both numerator and denominator by dt, what you get? Dy by dt divided by gamma times 1 minus v by c square times dx by dt. So dy by dt is ui divided by gamma times 1 minus ux into v by c. Yeah. Can you write it? uy prime is equals to uy divided by gamma times 1 minus ux into v divided by, so you notice that this thing and this thing is same. Similarly, if you calculate, let's say uz prime, uy and uz varies in a same manner, so it will be uz divided by gamma times 1 minus ux into v upon c square. So these three formulas are known as LT for velocity. So you see, if the velocity components are given in S frame, these are the formula which you can use to find the components in S prime frame. Now let's say the components in S prime frame is given, means ux prime, uy prime and uz prime are given, and if you want to go back to ux, uy and uz, how will you do that? That will be given by inverse Lorentz transform for velocity. Okay na? So you know what you have to do, you have to just replace v by minus v. Okay na? So we can also write the inverse Lorentz transform for velocity. In that it will be ux, uy and uz. So what was there? Ux minus v divided by 1 minus ux v by c square. Look, ux minus v divided by 1 minus ux into v by c square. What we have to do? We have to just replace it with prime and v will be minus v. Okay. Uy, it was the formula uy by gamma times 1 minus ux into v by c square. This was the formula, right? So it will be uy prime and v will be minus v. Clear? Just match it. Acha, this will be ux prime. Similarly, uz will be uz prime divided by gamma times 1 plus ux prime into v divided by. These are known as inverse Lorentz transformation for velocity. Let me know if everything is all right. Is it done, guys? Once you are able to find out the different velocity components, you can find out the magnitude of velocity by using this formula. U is equals to u root over u square root of ux square plus uy square plus uz square and square root of ux prime square uy prime square plus uz prime square. Okay, then we move forward. So mainly the first formula is mostly used. Ux prime is equals to ux minus b divided by 1 minus ux b by c square, and this formula ux prime plus b by 1 plus ux prime into b by c. So you should have the capability to understand what are those quantities. Then you can use the transformation rule and you are good to go. Reference, let's look at this problem. Reference frame B is moving with respect to inertial frame A with velocity c by 2 I cap, and reference frame C is moving with respect to inertial frame B with velocity c by 2 I cap. Velocity of C with respect to A is given by. If you can draw the picture, you will be able to solve the question. Three frames are given here, A, B, C. Reference frame B is moving with respect to inertial frame A with velocity c by 2. This is the first thing given to you, right? Let's say I'm just showing it in this way. This is our reference frame A. Reference frame B is moving. This is A. Reference frame B is moving with respect to A with velocity c by 2 I cap. So this is your I cap direction. So this is c by 2. So V is c by 2 actually. And reference frame C is moving with respect to inertial frame B with velocity c by 2 I cap. So another reference frame is there, and this reference frame is moving. This is C. C is moving with velocity c by 2 I cap. Velocity of C with respect to A. Do you understand this problem? I think you can do it. Velocity of C with respect to A. What does it mean? Do it, guys, quickly. So this frame C is like the B. Okay. So here, if you draw the analogy to what we have discussed in the previous section, here we can say what is V? V is the speed of B with respect to A, that is 3 by 2, right? Ux prime, this is the velocity of B with respect to C. So ux prime is C by 2. Velocity of C with respect to A means ux you need to find out. Okay, so you know the formula of ux. Ux is equals to ux prime plus V divided by 1 plus ux prime into V by C. Is this thing understood by everyone? Now you can just put the value, whatever value given. Ux prime is C by 2, V is C by 2, 1 plus ux prime is C by 2, V is C by 2, everything is C by 2. The CC gets getting cancelled, so 1 by 4. Ux prime is C by 2, V is C by 2, so 1 by 4 actually. But just put C by 2, V is C by 2 and 1 by. So this is 1 by 1 plus 2, 5. 1 by 1 plus 2, 5. So 125, 100 by 125 means 4 by 5. 4 by 5 C. And ux means I cap, so 4 by 5 C I cap. Option C. Yes, yes. Everybody understood this problem? Harry, Murli, what about you guys? The next problem which I am going to give you, that will clarify your doubts to more extent. Are you ready for the next problem? Just write done if it is done. If you have any question, you can ask. Chalo, let's do this problem. A car is moving with respect to ground along x direction with the speed c by 2. Okay, let's change the figure now. This is the ground. Let's say ground means S frame. This is your S frame. S frame is the rest frame. Moving with respect to ground along x direction with the speed c. Okay, कार is there, so कार का पिक्चर कैसा होगा दोस्तों? कार, let's draw a car. One wheel here, another wheel here. So this car is moving in the x direction with speed c by 2. Okay, so this is your S prime frame. No issue. A ball is thrown from car with speed c by root 2. As seen from the ground, the ball moves in y direction. So a ball has been thrown along y direction. So let's say this is your y direction. So the ball has been thrown along y direction. So it will only have components. A ball is thrown from car with speed c by root 2. As seen from the ground, the ball moves in y plus y direction. Calculate the speed of the ball with respect to ground. So actually, this is ui prime, right? A ball is thrown from car with speed c by root 2. So actually it has given you uy prime, that is c by root 2. Calculate speed of ball with respect to ground, means you have to calculate the magnitude of u. Is it clear or not? Calculate the speed of ball with respect to ground, means you need to calculate u. U is the magnitude of u, that is root over ux square plus uy square. So this is magnitude is given, right? The speed of the ball with respect to ground will be given by this. And what is the speed of the ball with respect to s prime frame? Ux prime square uy prime square. So the ball has been thrown along y direction, right? So first of all, what is v? A car is moving with respect to ground. Ground is the s frame, moving along its direction with a speed c by 2. So here v is equals to c by 2. There is no issue in this. As seen from the ground, the ball moves in plus y direction. What does it mean? Velocity of the ball with respect to ground. Let's write velocity components. Ground means s frame. Tell me, as seen from the ground, the ball moves in plus y direction. Okay. So ux will be what? 0. Can you write it? If you are seeing that ball is moving along y direction, means what? You are seeing that there is no velocity component along x direction. Uy, you do not know. You have just seen the ball is moving along y direction, but you do not know the velocity. Now velocity components of the ball with respect to car. Car is our s prime frame. So tell me here what will be ux prime? Ux prime we do not know. Uy prime is equals to c by 2. है ना? Because a ball is thrown from car with a speed c by root. So if you want to calculate speed of ball with respect to ground, means you need to know ux and uy. Ux you already know, uy you do not know. So what will be ux prime? Okay, ux prime, let's calculate. Ux minus v divided by 1 minus ux into v by c square. Ux is 0 minus v divided by 1 minus 0, so it is minus, so ux prime is equals to minus v. What else you require? You require uy. Is it clear till now? Look, a ball is thrown from car with speed c by root 2. Actually, this is not talking about the component, it is talking about the overall velocity. So it's, instead of writing uy prime, you just write u prime. U prime is c by root 2. Okay, na? In u prime, ux prime and uy prime both are included. Read this line: a ball is thrown from car with speed c by root 2. Means u prime is c by root 2. It means, okay, since the ball is thrown from the car, that is S prime frame, with respect to, okay, thrown from the car S prime frame with speed, with velocity c by root 2. What you can write? You know the formula of u prime. U prime square, if I write, it is ux prime square plus uy prime square, right? Now u prime is c by root 2. What is your ux prime? Ux prime is minus v plus uy prime square. So from this, uy prime square is equals to c square by 2 minus v square. Now v is equals to c by 2. Let's put the value: c square by 2 minus c square by 4. So this is your c square by 4. That means uy prime is equals to c by 2. Now we are in a position, once you get ui prime, we can find out uy. What is ui? Uy is equals to uy prime divided by gamma into 1 plus ux into b by c square. Uy prime is c by 2 divided by gamma is root over 1 by root over 1 minus v square by c square, so it is going up. 1 minus v square by c square, v is c by 2, so it is 1 by 4. 1 plus ux prime you have got minus v, so minus v square by c square, so v is equals to c by 2, so it becomes 1 by 4 with a minus sign. If you calculate it, what you get? c by 2 root 3 by 2 3 by 4. C by root 3. So we are now in a position to calculate the velocity of the ball with respect to ground S frame. Ux square Uy square. Ux we have got how much? 0. Uy C by how much? Root 3. Option C. Let me know if you have any doubt. Anyone has any doubt? Should I repeat the problem or you have understood? Should I repeat or is it okay? Harry, Murli, Ajay, could you understand or not? Okay. I am just showing you it here, then I will delete. Look. What is given in the question? That a car is moving with respect to ground along x direction with speed c by 2. So this direction is your x direction. Okay. A car is moving along x direction with speed c by 2. It means it is v. V is equals to c by 2 with respect to the ground. Ground means s. Simple. Now a ball is thrown from car with speed c by root 2. The ball has been thrown from car. So the ball will have speed u prime. U prime means it is containing of ux prime, uy prime. So from these two components, when you define, you get the speed of the ball with respect to s prime, and this overall thing is given to you as c by. So this is with respect to a person, let's say, which is sitting in the car. Now a person from this ground, he will measure the speed of the, he sees that the ball is going along y direction. Okay, now so he will measure the speed as u, but as he sees it along y direction, what does it mean? In normal classical physics, if you see, if something is moving along y direction, what will be its speed along x direction? Obviously it is 0, right? So that is what this man is seeing this ball to move along y direction. It means ux will be definitely 0 and uy, he sees it but he does not know the value. Okay. Now how many things are given? you are given ux is equals to 0 and u prime is equals to c by root 2. These two things are given along with the speed of the car with respect to current, means v. These three things are given. Now you have been asked that what is u, means what is root over ux square plus uy square. This thing you have to know. So ux you already know, uy you do not know. To know uy, you need to find out the ux value, ux prime value, okay, because in the formula of uy you will require ux prime. So ultimately what is lacking here, you are lacking uy. You need to find out ui. To find out ui, you need ui prime and ux prime. So we have evaluated these two things because ui prime is dependent on ux prime, so we have found out ux prime first, then using that data we found ui prime. Once you got ui prime, we got uy, and once you got ui, we got u. This is what it is. Now understood? Okay, I think we should stop it here. On the next day we will go for time dilation, length contraction and many more things. So you got the basic idea, just revise these things. This is the main thing, and the remaining thing you will understand eventually. Many questions, most of the time questions come from this velocity addition formula. Velocity addition formula means it is talking about this, mainly this formula, this formula and this formula. These are called velocity addition formula given by Einstein. With this note, let us end the session here. Thank you very much guys for joining the session, and see you guys tomorrow. Till then, bye bye, take care.